Oddly, have you ever considered that Earthlings might really not be the only species present in the universe? In fact, a bizarre occurrence has begun to unfold in the solar system closest to ours. Proxima Centauri, located just 4 light-years distant from ours, seems to shroud something in secrecy. And recently, scientists have begun to detect some weird signals from one of the system's planets, Proxima B. This weird occurrence, tagged artificial lights, have been giving scientists countless sleepless nights, and how they came to be, most importantly. Could this be some not-so-distant neighbors trying to pass some crucial information across? Stick to the end of this video as we talk about the strange discovery of artificial lights made by the James Webb Space Telescope on Proxima B. Just before we dive in, don't forget to click the subscription button and hit the notification bell to stay connected to our channel whenever there's the latest news. Alright, let's go. On a scale of 1 to 10, what are the probabilities of another species existing in the solar system aside from humans? None, right? Yeah, these were our thoughts until late 2020, when a signal was detected from the direction of Proxima Centauri, our nearby neighbor star named BLC-1. To date, these signals are still probed to make sure this signal is not the aftermath of Earth civilizations, which they usually turn out to be. As a result, scientists are turning their focus to planets and Proxima Centauri to find out what this strange occurrence might actually be. From space, one clear indication of human existence has to be the luminescence of our city lights at night. Somehow, these lights have managed to break loose into the cosmos, radiating their glory from space. However, back then, what poses more of a problem was the outdated versions of telescopes employed by scientists. In short, these telescopes were usually not powerful enough to detect illuminations from far places. This seeming shortcoming has led experts to the development and assessment of successive telescopes. And voila! We are looking at the new and ultra-modern James Webb Telescope, powerful enough to detect another race aside from mankind. Better still, if things play out so well and we eventually develop our technical shortcoming of space observation, we might be able to confirm if Proxima Centauri is indeed home to another civilization. And more than anything, scientific research could also be conducted on Alpha Centauri B to determine the origin of artificial lights discovered. Even more interesting, Proxima Centauri from previous studies has proven to be a habitable area sharing almost the same mass as the Earth, while orbiting the closest star to our very own planet. Thankfully, updated and ultra-modern instruments like the latest James Webb Space Telescope and the Large UV Optical IR Survey, better known as LUVOIR, would be utilized in the study of these artificial lights. As a multiple wavelength space observatory, one might think this is an impossible feat to pull off, but remarkably, it has an intended launch date for 2035. To back up claims about the prowess of these highly advanced instruments, authors Elisa Tabor of Stanford University and Avi Loeb of Harvard point out that a tidally locked planet with a permanent night side would need artificial lighting to support a technological culture. And this brings us to the possibility of civilization emerging from nearby stars as something impossible, only existing in dreams. Looking at it from another angle, a civilization springing from another world can be identified through the artifacts left behind in worlds these aliens picked to traverse. By making use of the JWST camera, there are a few approaches to detect the existence of alien technology in a distant world. Take, for example, the numerous constellation of satellites that can help us catch a glimpse of light from a distant world. In fact, with the exploding number of satellites launched into orbit, there is also an unusual coincidence of events taking place on Earth also being reflected in space. Take, for example, atmosphere pollution might just be detected from nuclear wars. Does that ring a bell? Nevertheless, all these signs of technology could possibly boil down to natural phenomena such as comet collision or orbital debris, and as such, artificial lights are, just so different from the natural lights of the stars. Last year, scientists Elisa Taber and Avi Loeb embarked on a virtual extraterrestrial light search with the JWST, and the findings derived were a little inferior since JWST wasn't entirely functioning back then. Presently, the main target of the JWST is the Proxima B planet, the only Proxima Centauri planet located 4.25 light years from Earth. Now, you may wonder, what makes this planet so interesting for scrutiny? A lot, actually. The Proxima B planet is the only verified planet with rocky terrains and just the right conditions to support the existence of another civilization. Located in the habitable zone of the M-class red dwarf star, Proxima Centauri B is measured at just 12% of the mass of the Sun. And here is another fun part about Proxima B. Aside from sharing almost the same mass as the Sun, it is quite heavier than our planet at about 1.6 Earth masses and 1.3 times our radius. In addition, it orbits Proxima Centauri in just 11.2 days at a distance of 7 million kilometers. Only 5% of the distance the Earth orbits the Sun, and as a part of the solar luminescence reflected by our planet's day side, therefore causing artificial light to scale up. On this scale, 0% in place of the planet's night side is entirely dark, but 100% would suggest the planet's night side and day side are both equally bright, which is, well, quite possible. Based on findings, it has been assumed that the illuminations used by the suggested civilization on Proxima B share similar traits to LED lights used on Earth. So what are we in for? To put it simply, if JWST manages to uncover the artificial light with an accuracy of 85% certainty, and Proxima B artificial night side illumination exceeds 5% of the natural day side illumination, then Webb's detection rate would increase to 95% if artificial light gets to 9%. Sure, you may think 5% doesn't sound too great, right? But the thing is, we are discussing the illumination from a star, and the Sun has been proven to be 20 times brighter than Proxima Centauri. To put it visually, you can think of it as placing a firefly next to a stadium light. However, even that much light at the cosmic level is massive. In comparison to Earth's artificial light, only 0.001% of reflected stellar light is represented by artificial lightning on Earth. So, if Proxima B happens to host another civilization as intelligent as Earth, unfortunately, Webb won't be able to capture it. More so, these lights would need to be 500 times brighter than usual. That alone is quite convincing if you consider Proxima B's closeness to its host star, tidally locked with one part of the planet facing the star, while the other is kept in eternal darkness. In fact, the civilization of a tidally locked planet would most likely need to focus on its lightning infrastructure and very bright orbital mirror to reflect sunlight onto the night side of the planet, which could be detected by our space observatories. But that's more or less like a guess. This conveniently brings us to the advanced technology of the Large UV Optical Infrared Surveyor, best known as LUVOIR, and the Habitable Exoplanet Observatory HABEX, which Taber and Loeb claimed might just be more powerful than JWST in detecting the glow from a faraway civilization. A few days after, Thomas Beatty from the Department of Astronomy, University of Tucson, explained how the LUVOIR and HABEX could comprehend how space observatories could capture the city's illumination, not just on Proxima B, but also on planets orbiting stars at outward distances of 30 parsecs or PC. Mind you, 1 PC is measured at about 3.26 light years. Interestingly, both LUVOIR and HABEX are both set on a mission of recording and directly picturing exoplanets. However, with the launch date set for 2035, truthfully, there is still a long way to go before then. At this junction, Thomas Beatty comes in. By making use of virtual LUVOIR and HABEX, Beatty observed several systems with famous planets like Proxima B, and of course, theoretical habitable planets orbiting G, K, and M-class stars. In addition, he scaled the percentage of the planetary surface which was urbanized. You see, the more the urbanization, the brighter the planet's night side becomes. And the sort of light used in this model imitates high-pressured sodium light prevalent on Earth. Besides, these lights feature a spectrum of light different from natural starlights. At this point, 3 things are more likely to occur. 1. The variables are far away from Earth. 2. The planet's level of urbanization. And 3. The type of star the planet is orbiting. In each instance, the virtual scopes are capturing planets for a minimum of 100 hours in order to receive adequate light coming through the instruments to better comprehend the target. For your information, only 0.005% of the Earth is urbanized. Besides, our telescope won't be able to detect us if it was positioned from Proxima Centauri. For instance, if urbanization reached about 100%, it will be possible to view a detailed extraterrestrial society more clearly. Hold on for a sec. What do we mean by 100% urbanization? This all boils down to a term dubbed ecumenopolis, a situation whereby a city, planet, or world spans its entire surface. And yeah, we know, it sounds like something that popped out of a sci-fi movie, right? What's more interesting is that there are already several cases of such cities like Coruscant, the empire capital of Star Wars, and the ecumenopolis planet type in the video game Stellar. Outside the realm of science fiction, even our Earth has been predicted to become fully ecumenopolis some years down the line. Quite unrealistic, isn't it? Thankfully, future space observatories will be able to discover the ecumenopolis regions around 82 stars close to the Sun, and that's a whole lot of space. So, if an extraterrestrial fella decides to shine that brightly, we might just be able to discover them in the coming decades. An extraterrestrial beacon. Now, to the juiciest bits of today's video. As it stands, Proxima B is the main target for discovering ecumenopolis worlds out there. This validates claims from BT's research about close-by red dwarf stars being the best chance of discovering more urban worlds out there. With these telescopes, scientists could identify about 5% of urbanization on the planet, which is 10 times greater than Earth's urbanization. Quite surprising if you'd ask me. Not just that alone, by making use of the next generational telescopes, it would be incredibly easy to find ecumenopolis such as Proxima B. And here's an interesting fact. Within the next century, the Earth would have expanded by only 0.5%, according to data derived from the current city growth rate, which is more or less like a blink in cosmic times. Therefore, if an extraterrestrial civilization does exist, it might have reached an increased scale of urbanization. That is, if they have a long lifespan. This is one irresistible fact we may never know, except if someone out there tells us otherwise. Who knows? The extraterrestrial beacon might just be aliens out there seeking our help. For now, let's keep our fingers crossed and watch as events unfold in the nearest future. As usual, thanks for watching today's video. One more thing, let us hear what you think about those lights on Proxima B and how early you think Webb and other space observatories should begin providing desired proofs.